Hello Year 12, today we're going to be looking at logarithms, instructions, follow. So there's essentially two things that I want you to do today. The first task I'd like you to do is to spend 45 minutes on this exercise on these questions. So I'd like to do question 1, 2, 3B and C, 5 and 6, but obviously only spend that time on it. Don't try and complete all of those things. I put some little hints as to what you need to do, and the answers are in the team, so check through as you're doing them. The other thing I'd like you to do is I'm about to go through 4 extra examples that we haven't seen on exponentials and logarithms on the next 4 slides. I would like those to have notes made on them, so copy them up and show how we do them. There is a homework set, it's a variety of log questions, it's also in the team. So let's go. So this first one is a simultaneous equation that involves e and logs and x and y. What we want to essentially do with all simultaneous equations is to substitute. Now, if you think you know what to do and want to have a go first, that's fine, but I'm going to crack on. You can, of course, pause the video at any stage. So what I'm going to do is I'm going to rearrange this bottom equation to be 2y, so I'll move that across to the right-hand side, is equal to ln of x plus 3 minus 1. The reason I'm going to do that is I can take this 2y and I can substitute it in to e to the power of 2y. So we can make that e to the power of ln of x plus 3 minus 1, and then minus x plus 2 equals 0. Why have we done that? Well, e to the ln cancels out, and we've just got to deal with the fact that we've got this minus 1. So how are we going to do that? Well, we can split apart this index here using index rules and say that we have e to the ln of x plus 3 times e to the minus 1. So obviously, if we times things together in an index, those would be added together. Minus x plus 2 is 0. And then we can tidy stuff up. So e to the power of log x plus 3, the e and the log cancel. We've got x plus 3 times e to the minus 1 minus x plus 2 equals 0. And now we're basically home. So all we need to do is to get x on its own. We need to make that the subject. So we'll basically do Mechford, as I've been suggesting before. We don't need to multiply anything, but we will expand. That will give us x e to the minus 1 plus 3e to the minus 1 minus x plus 2. We'll then collect our x terms together, should say equals 0, which will give us x e to the minus 1 minus x on the left hand side, and we'd have to subtract the other thing, so minus 3 to the minus 1 minus 2. We're then going to take out a factor of x, so x e to the minus 1 minus 1 is minus 3 e to the minus 1 minus 2, and then we'll divide. So we'll get that x is equal to minus 3e to the minus 1 minus 2 all over e to the minus 1 minus 1. Looks absolutely horrendous, but all you need to do is stick that in your calculator, which will give you that x is equal to about 4.91. Now obviously it's a simultaneous equation, so we need to find y as well. So we're going to again use this equation and substitute in that x is 4.91. So 2y equals ln of, what would that be, 7.91 minus 1. So y would be a half of ln 7.91 take away 1, and that gives you y is 0.53. Okay, so that was an 8 marker. Let's look at ones that take a little less time. So we've got here ln of 2x minus 3 equals 1. This should be one that you can do now. You've been looking at exercise 14G. First thing we want to do is obviously raise e to the power of the other side. That's how we get rid of logarithms. This is a base e, so it's going to be a base e on the other side. And it wants answers in exact form, which means we don't want to do any sort of decimal calculations at the end. So we'll add the 3, and to be honest, we don't really need to say e to the power of 1, that's just e. And then we'll divide by 2. So our answer for the first one is simply 3 plus e over 2. For the second one, this is one of those substitution ones. So we need to say something like, well, the first thing we need to do is multiply everything by e to the y. So if we do that, we're going to end up with 3e to the 2y plus 5, because that cancels out with e to the minus y, doesn't it? It gives you e to the 0, which is just 1, is equal to 16e to the y. So what we did was we times everything by e to the y. And then we're going to make a substitution. We're going to say that we've used x and y. Let's use k. Let's say k is equal to e to the y. And more importantly, that means that k squared is e to the 2y. So we'll end up with 3k squared plus 5 is 16k. Now that is a quadratic. It always is. So we'll subtract the 16k, and we'll end up with a quadratic that can be solved in any number of ways. I'm going to go for a factorization, but you could do that with quadratic formula if you wanted. Then we'll simply get that k is 1/3 from the first bracket and k is 5 from the second bracket. Now obviously we don't want k, we want y. So we have to go back into what we said, that k equals e to the y. And if we sub that in, we'll get that e to the y is 1/3, or e to the y is 5. And so if we want to get y, we need to take a log of both sides. So we've got log 1/3, and we've got log 5. Now it says give your answer in exact form, and we have. So we don't need to work these out as decimals. Okay, 2 more to go. Right, so 3a has a very interesting question here. Technically this is something called the change of base formula, but I'm going to show you how it works. So we're given that y equals ln of x, and we want to find expressions in terms of y for log base 2 of x. So this is what we're going to do. We're going to start by saying that that log base 2 of x is just k, and we're going to try and figure out what k is. Now what we can do is we can use logarithm rules and get rid of that base 2 and use it as a power on the other side. So we can say that the equivalent log statement to that is that 2 to the k equals x. And then we look at the logarithm we're trying to get. We're trying to get ln x. So we'll take ln and put it on both sides of the equation. And then we'll use the power rule to get that k out of the log. So we've got k log 2 is log of x. So what did we want to do? Originally we wanted to find out what k was. So we just need to divide across by that log 2, and we'll get that k is log x over log 2. Now we said that k is log base 2 of x. We know ln x, according to the question, is y over ln 2. So that's our expression for log 2x in terms of y. So yeah, change your base, that one. Fairly funky formula, but you define something and then you take logs of both sides of it. As for the second one, that's probably a little bit easier. So we've got ln of x squared over e. What you would do is first obviously split that into a subtraction, not a division. Nearly made a horrendous mistake there. That's the same as ln of x squared minus ln e. That's just the subtraction rule for logs. We can then use the power and say that that's equal to 2 ln x. And then ln e, that cancels out completely. It's a log base a of a. It's just equal to 1. We want to find this in terms of y. So y is log x. So we can get that our final answer will be 2y minus 1. And then part B has this great word, hence, which means use the thing you just did. Now we've got here log 2x is the thing it starts with, is equal to 4 minus ln of x squared over e. And what we're going to do is swap in the things we found. So we found that this thing on the left hand side is y over ln 2, and we found this thing on the right hand side was 2y minus 1. Just be careful that that's all in a bracket because we're taking away the whole thing. First thing I would do with this is expand that right hand side. So that's going to be 4 minus 2y plus 1 because it's minus minus. So let's go even one step further and say that's 5 minus 2y. And then I want to solve this equation. So I want to get y on its own. So it's essentially back to Mechford. So we'll multiply both sides by that ln2. So we'll end up with y equals ln2 times 5 minus 2y. We'll then expand that bracket and we'll end up with y is 5 ln2 minus 2 ln2y. That's a very pleasant thing. We'll collect our y terms together. So we'll have y plus 2 ln2y is 5 ln2. We'll factorize. That'll give us y brackets 1 plus 2 ln2 is 5 ln2. And we'll divide. And we'll end up with y is 1 plus 2 ln2 over, wrong way around, is equal to 5 ln2 over 1 plus 2 ln2. Now what do we actually need to do? Well, we could work that out as a thing, I suppose. And we can get that's equal to 1.452. But then we've got that y equals ln x, and the question was to do with x in the first place. So that will tell us that ln x is equal to 1.452. And so if we want to get x, we have to go e to the power of 1.452. Which will give us for our final answer 4.27, because the question says give your answer to 2 decimal places. So yeah, really key thing is the word hence there, and obviously solving the equation given stuff we've already done. So yeah, 3 fun log questions. Make sure that you've got those copied as examples, and the homework is set in the team. See ya.